Salam sejahtera. My name is Victor Tengkok Leong. Today I'm going to present you my topic which is on the infrared thermography for building inspection at Bangunan Sultan Iskandar, Kuching. So what is my innovation about? In a common situation in most developed countries, especially in Malaysia, where the utilization of ratio of source of energy is low, so the reliability of service equipment is not up to par, and the cost of installation and planned preventive maintenance is high, and the loss due to less than stellar upkeep is heavy, and so on and so forth. Therefore, it is recommended the agency in need of using infrared thermal imaging technology or technique to improve the energy saving procedure. So the equipment diagnosis as well as fire searching. II thermology is now displayed as an extremely useful tool in the study and advancement of energy efficiency in the building. Thermal imaging systems are used as a tool to detect, to recognize, and also to identify the structure, lift, and other equipment used inside the buildings. They can also be used to evaluate the health of any electrical or mechanical component. This paper presents infrared inspection surveys or insulation or TIM and the temperature of the electrical installation inside Sultan Iskandar building located in Kuching. So the location of the case study. Okay, a case study is nothing but a process of research in the domain of project over a period of time. To fulfill the objective of research, a site has been chosen, which is Bangunan Sultan Iskandar, which is a federal government complex located at Jalan Simpang 3, 950 Kuching, Sarawak. It is an 18-story building, and the building owner belongs to the federal government. So, the methodology of this research. Thermal imaging was conducted thoroughly on related components specified. Images with high temperature will be highlighted on the hottest point for every component. Detailed analysis will provide quantitative measurement results with high degree of accuracy for operation and process assessment to prevent unforeseen breakdown and to improve the maintenance efficiency. With these thermal images, it is possible to identify the fault as a loose connection or overload circuit, the most common in the electrical fault. So, the scope of this study consists of the location found at the Bangunan Sultan Iskandar. There is a total of 5 locations. Location number 1 is the MSB room or the main switchboard room. The second one is the plant room or the switchboard. Third is the electrical riser or the DB from the ground floor to the 17th floor, and also the air control room from the ground floor to the 17th floor, and also the lift motor room. Based on the thermal energy done, which is conducted on the 2nd, 9, 16, 23rd, 30th, on the Thursday, and also on the 3rd, 10, 17, 24th, or 31st on a Friday, in the month of January 2020 at Bangunan Sultan Iskandar. It can be concluded that the problem classified on all the building electrical system ranges from minor problem to a critical problem. Most of the problem due to high load and also the loose termination of the connection of the cable. For the intermediate and critical problem, it is highly advisable to follow the recommended preventive measure taken. Okay. However, it is advisable for the operation personnel or person in charge to consistently monitor the load demand, points of area, classify rating, and also the connection termination, as well as the problem at the minor level and also at the major level. Okay, for the table 1, which is a reference based on temperature rise, courtesy of the International Electrical Testing Association. From this table, there is 4 classification of problems, okay, for minor, intermediate, and serious and critical. So, for the minor, there is 1 to 10 degree difference based on the comparison between the component and ambient temperature. For example, if the ambient temperature is 30 degrees Celsius, okay, when you do the measurement, it's around 31 to 40, increase from 30 to 40. This is considered minor problem. Okay, so what you do with the minor problem? You just do monitoring. Okay, let's say intermediate. The ambient temperature is 30. Suddenly, based on your measurement, it's up to 60. It's a considered intermediate problem. So the next step will be do a repair as time permit. Okay. The next one is a serious problem. This means from 30 you increase until 60 or 70. This is a serious problem. So need to monitor until the corrective measure can be accomplished. So for the critical one, 30 degrees Celsius is increased by more than 70 degrees Celsius. So the next recommended action to be taken is measure discrepancy or repair it immediately. So this is a brief summary of all the results taken using the thermal imager at the Bangunan Sultan Iskandar. The first example is a lift motor room. Equipment is MCCB termination. Detection of unsafe condition. Found that the spot and blue phase incoming to the MCCB 400 ampere lift motor room and the temperature rise to 60 degrees. So this is a total of increment of more than 30 degrees. Okay. So the second condition is the 17th floor, right wing, switchboard room. The equipment is switchboard, blue phase bus by. Found the temperature rise at the blue phase joint about 47.5 degree. So should be around 70 degree of the ambient temperature. This is considered a minor problem already. Okay, not a major problem. So at the 16th floor, right wing air shoe room, equipment and MCB electrical distribution board. Okay, found hotspot at MCB termination is about 60.4. So increment of around 30 degrees Celsius of ambient temperature. From the left is the imager and the right is the real image. So the 12th floor at the right wing air shield, equipment is RCCB. Found a hotspot in the blue phase combination. The temperature rise until 47.8. Okay, this is an intermediate problem. So you just need to monitor it. So at the 11th floor right wing, DB, equipment MCB at electrical distribution board. So detect MCB termination heater and far hotspot at around 53. So increment around 23 degree. So you need to do minor adjustment or minor tightening of the connection at the hotspot. So at AC pump room switchboard, the equipment is capacitor bank. Okay, found that at the third step capacitor bank wire termination, temperature heated about 97.3 degrees Celsius. This is a critical problem. So immediate action need to be taken. Okay, because it's more than 60 degree increase of the ambient temperature. So an immediate action need to be taken to fix this condition to avoid any breakdown or fire. So the MSB insertion board equipment man SCB bus bar termination found that the SCB termination and temperature rise above 51.9. Okay, so this one also need to do a tightening of the termination. Okay, so from the next result, okay, this is a compilation of all the example given. Okay, from example 1 critical intermediate until the rest is very serious. Okay, so need to do in immediate action. So the table 3 is a recommended action to be taken based on the finding. Okay, for this photo room, the action need to be taken is to tighten the loose connection at the blue phase and the MCCB. The second one, you need to tighten the loose connection at the blue phase also, and also due to unbalanced power loading. So you need to do a load balancing at the second one. Okay, the third point, the loose MCB termination, you need to retighten the cable so the system can return to normal. For the fourth one, say a suspect a loose connection at the blue phase at the RCCB due to load balancing. So you need to retighten the blue phase cable at RCCB, which is the result of the rise in the temperature drop. Okay. So the point 5, to submission and high load at current at CB, you need to retighten the cable termination and the system should return to normal. So point 6, the fault at capacitor band loose connection at capacitor, you need to retighten the termination also. The last one, MSB room, there is due to unbalanced load of loose submission and red phase resulting in increase in temperature. So you need to inspect then retighten the termination also. So in conclusion, thermal image provide an excellent tool for rapid assessment electrical system inside the building. So we can detect the problem immediately, we can find fault in the system, so immediate action can be taken. This is a non-contact and non-destructive method is useful in rapid condition of survey electrical system without requiring any access to open the trunking or the underwire. Because you don't need to open the DB, you just do a imaging, you can see which is the hotspot. After that, is there a problem, you can open it, then you do your maintenance work. You don't need to open one by one, which is a lot of process. Okay. Lastly, any corrective measurement can immediately be taken to avoid any breakdown or disruption to the electrical supply that may happen in the foreseeable future, thus saving tons of money in repaying the cost of the building owner and also the management firm. This is to prevent any future breakdown, and this can cost saving also. Moreover, by doing preventive or corrective maintenance, efficiency of the electrical system inside the building can also be improved greatly. Thank you. That's all from me. Hope to see you again.